For this lesson, we're going to be doing linear inequalities level 1, and there's no number line, so we just have to worry about getting p all by itself, or whatever variable we're solving for, and then inputting our answer and typing it in with the correct symbol. When you look at what you're given and how you're typing in your answer, you can see that p, or whatever letter variable that you're using for your answer to type in, is on the left. So to make it easy on myself, whenever I'm solving this by hand, I'm just always going to get my letters to the left and my numbers to the right. So in this first example, I have p plus 1 is greater than or equal to 9p plus 5. I just talked about when we were looking at how we type it in that we're going to get our letters to the left. So I'm going to take my 9p and get it to the other side. 9p is positive, so to get it to the other side, I will subtract. And I have to make sure that since I'm working with variables, I want to combine it with like terms. So I'm not going to put it underneath the 1 because that doesn't have a p on it. I'm going to put it underneath the other p. So now p minus 9p gives me negative 8p. Bring down my plus 1. Bring down my greater than or equal to symbol. Bring down my 5. I'm going to keep solving, so I want to get my 1 to the other side now so that my p is all by itself on the left-hand side. So my just number part, my 1 is positive, so I'll subtract 1 from both sides. So now I have negative 8p is greater than or equal to 5 minus 1 gives me 4. My last step is to get the negative 8 to the other side. It's attached to the p with no symbol, so that means multiplication. We need to do the opposite, so we're going to divide the negative 8 off. Since we're dividing by a negative number, we remember that rule from the last lesson that means I need to flip my symbol around. So instead of greater than or equal to, it'll now be less than or equal to. On the left-hand side, all I have left is p. On the right, 4 divided by negative 8. I can simplify it to negative a half or negative 0.5. I'll go to delta math. P is less than or equal to negative 0.5. Our next example, again, I'm going to get all my m's to the left, all my numbers to the right. So I'm going to start out by getting this m to the other side. It's positive, so I'll subtract m from both sides. 4m minus m is really like 4m minus 1m, so I get 3m. Bring down the minus 5, bring down the less than, bring down the 2. I want to keep getting the m all by itself, so I want to get the negative 5 to the other side. It's negative, it's being subtracted, so I'll add it to both sides. (3m) on the left is less than 2 plus 5 gives me 7. And now I want to divide both sides by 3. M is less than 7/3. If you went to type 7 divided by 3 in your calculator, it would give you your long repeating decimal 2.33. I'm not going to input that into my calculator and write out that repeating decimal into delta math because it's repeating. I'm just going to leave it as the simple fraction 7/3. So I need to make sure I have the correct symbol, less than, yes, and then 7/3. And I just used the question mark keyboard button on my laptop to do the division, 7/3. And then our last example, we're going to again get all the g's to the left-hand side. So I have a positive 2g. I want to get it to the other side by subtracting. G minus 2g is really like 1g minus 2g, so I get negative 1g plus 8 is less than or equal to 5. I want to get the g all by itself, so I want to get the positive 8 to the other side. It's positive, so I'll subtract it. I now am left with negative 1g is less than or equal to 5 minus 8 gives me negative 3. My last step to get the g all by itself is to divide both sides by negative 1. But you can't forget that since we're dividing by a negative number, you have to flip this symbol around so now it's greater than or equal to. So I get g is greater than or equal to negative 3 divided by negative 1. Negative divided by negative gives me positive 3. So I'll go to delta math. G is greater than or equal to, and we said it was positive 3.